Welcome back to another session of Code Along with Alex. I'm Alex, and let's just get right into it. So we're going to look at the use declaration in the Rust by example documentation. So I'm going to toggle right to the code so I don't spoil the fun, but let me read some of the blurbs that are there. The use declaration can be used to bind a full path to a new name for easier access. It's often used like this. So instead of just reading, let's get to coding. Let's do a cargo project called cargo new. The use declaration. Okay. And then let's change into that directory and open main.rs. Okay. So let's declare crate. We're going to use crate deeply nested. Oh no, oops. Deeply nested. And then we're going to pass my first function, my second function, and a trait type. Cool. And then a semicolon. And then let's replace our main function body with my first function. And then this is kind of pseudocode, so I don't think it'll actually run necessarily. Let's try. Yeah, okay, because that crate doesn't really exist. Okay, cool, but that was more of just like a pseudocode example. So you can also use the as keyword to bind imports to a different name. Yeah, so I don't actually have a deeply nested. Let's do this anyway. Okay, so use deeply nested function as other function. Cool. And then function println macro called function. Great. Next, can't forget that semicolon. Let's declare a module called deeply. Okay, this is where things will get interesting. Deeply. And then inside there's a nested module called, a nested public module called nested. And then inside that, there's a public function called, you guessed it, function. And that'll just invoke the println macro and returned called deeply nested function. Cool. And now let's get right into our main function body. So function main, other function, and then the println macro, entering block. Okay, now let's create our block. Use crate deeply nested function. Cool. I like the autocomplete. And then function, nice, print ln leaving block. And finally, after we've left the block, let's invoke function. Let's press save and then do cargo run again. Very nice. And so you can see at first we called the deeply nested function, which is other function. So interesting. So other function is just deeply nested function, aliased essentially. And then we entered the block, and then we called deeply nested function again. And then we left the block, and then we called the other function we defined. Okay, interesting. That makes sense. Well, that was a little quick tour of the use declaration. So next, let's take a look at super and self. So if we toggle to the docs, it's just a little bit of text to read, so I don't want to spoil the code fun. But the super and self keywords can be used in the path to remove ambiguity when accessing items and to prevent unnecessary hard coding of paths. So let's create a new cargo project, super and self. Change into that directory and then get right into it. So to start, I'm going to declare a function called function, and it's just going to use the println macro and return called function. Spelling. Okay. Next, let's declare a module. Inside it'll have a public function called function, and that will just invoke println macro and return that it called cool function. So cool. Okay. Next, let's declare another module called my. Accidental, too many curly brackets. So this will also have a function called my function, or called function, but it is private. And then it'll return invocation of the println macro, just letting us know that we called my function. Okay, inside of this, let's declare a nested module called cool. Inside that, a public function called function, which invokes the println macro and just lets us know that we called my cool function. Nice. And then we'll declare one last function before our main meat and potatoes main function. Okay, so here, let's call this pub function indirect call. So print macro not println called my indirect call. Isn't that weird? New line business that we saw last time, because the print macro does not trigger a new line. Okay, then let's invoke self function. And this, the self refers to the current module scope, which in this case is my. Then calling self function and calling function directly both give the same result because they refer to the same function. Cool. Then, speaking of cool, let's do self cool function. And this, you can use self to access another module inside my. And then you can also do super function to refer to the parent scope outside of my. Neat. And then let's create a block for ourselves. And inside here, let's use create cool function as root function. And then let's invoke root function. Awesome. Delete the extra new lines. And then right into the main function body, my indirect call. Let's save this. Let's run. Oh, cool. So you can see we called my indirect call, called my function. Nice. And then we called my function, called my cool function, called cool function. And you can see we're just calling these toy examples, but it's really just building some intuition on how we're able to access nested functions and modules from within each other using super and self. So that's pretty cool. I think this will help me long term. And then I guess finally, we're gonna move on to file hierarchy. And so modules can be mapped to a file directory hierarchy. And so let's break down the visibility example in files. So let's create, this won't be a cargo project so much as just a directory. Make dir. Let's call this file hierarchy. And then let's change into that directory. Okay. And then let's create some files. So to start, let's make split.rs and my.rs. And then let's make dir my, and then we can touch my inaccessible. Oh, apologies, you cannot see my code. But I'm just recreating that file hierarchy from the docs. Inaccessible.rs and my/nested.rs. Okay, and you can see we have all the files we'll need. To start, let's create or add content to split.rs. So you can see I've opened that. And let's just get to typing. So this declaration will look for a file named my.rs and will insert its contents inside a module named my under the scope. Okay, so mod my, and then let's declare a function called function that just invokes the println macro and lets us know we called function. And then the main function body will just be my function, my indirect access, and then my nested function. Okay, cool. Let's save that. Close this file. Next, let's move on to my.rs. So similarly, mod inaccessible and mod nested will locate the nested rs and inaccessible rs files and insert them here under their respective modules. So mod inaccessible, spelling is weird sometimes. Accessible, okay. And then pub mod nested. Cool. So to start, let's declare a public function called function, which just invokes println, lets us know we called my function. Next, let's declare a private function called private function, and this will invoke println macro, letting us know we called my private function. Okay, and then we'll do one last function in this file, public function, indirect access. Here we'll just use the print macro called my indirect access that, and that new line, silliness. Okay, next we're gonna, one more thing here. Within indirect access, now we have to invoke private function. Awesome. Okay, now let's move on to my/nested.rs. Here we're going to define two functions, pub function called function, invoke the println macro called my nested function. Next, we'll declare the allowed dead code flag for ourselves, just so the compiler doesn't get angry at us. And then a private function called private function. And this will also invoke the println macro and let us know we called my nested private function. Okay, that's it for this file. And then finally, we're going to update my/inaccessible.rs. So again, the allow dead code flag for ourselves, or for the compiler, and then a public function called public function, and it invokes the println macro, lets us know we called my accessible public function. Awesome. Save that. And then let's just close this file. Everything looks good here. Or let's do the, I don't have tree. Oops. Okay. Should install that. So to start, let's run rust c split.rs. So we're avoiding cargo intentionally on this lesson just because the instructions want us to use rust c. Yeah. So you can see we called my function, then we called function, called my indirect access, that called my private function, and then called my nested function. So you can see we replicated the previous behavior across multiple separate files. So that's pretty cool. And that's been our whirlwind tour of modules. If we toggle back to the docs, you can see that's it. Next time we'll dive into crates, but thanks for joining me on this kind of shorter session. I'm Alex. This has been Code Along with Alex, and see you next time.